Hi class, this is Neil and this is lesson 10, second video. In this video we're going to go through the three examples that are a part of this lesson. So the first example is a little bit different than things we've seen before in that we're going to be given a formula and we'll need to kind of use what we know about exponential equations and the information that's given to us in the problem to help us figure out how to use that formula. All right. I apologize in advance if you hear piano playing or singing. That's my upstairs neighbor who's a musician, so he's practicing right now, and you might hear him in the background. All right, so using the formula below, determine the monthly payment. So we have a monthly payment here on a 5-year car loan with a monthly percentage rate of 0.625% for a car with an original cost of $21,000 and a $1,000 down payment to the nearest cent. So what we're looking for here is the amount of the monthly payment. Then we're given this kind of big formula with a lot of stuff that we've never seen before. Luckily, everything in this formula is defined for us. So we're told what each thing means. So P of N, which is the first part, is the present amount borrowed. So if we have a car that costs $21,000 and we make a $1,000 down payment on it, to buy that car, we would need to borrow the amount of the car minus the down payment. So that's $21,000 minus $1,000, or $20,000. That's the amount we would need to borrow. Okay, the next thing in this equation is N, which is the number of monthly payment periods. Well, it's a 5-year loan, and if the payments are monthly, it's happening 12 times a year. So that means we would have a total of 60 payments. Okay, then we're given this sort of 3-letter variable, PMT, which represents our monthly payments. Just so we don't have to write those 3 letters quite a bit, let's just say PMT is X. Okay, next we have our interest rate. Well, our interest rate is told to us as 0.625%. We'll need to write that as a decimal, so 0.00625. Okay, so to do this then, I'm going to need to just be careful about how I'm inputting things into the equation. So I'll start with that P of N. We found that to be 20,000. And now we don't know what our monthly payment is, so that's X. And now I just need to be careful here about how I'm inputting what's on the top of this fraction. So 1 minus, parentheses, 1 plus our interest rate, which is 0.00625, raised to the power of negative n. Be careful, because it does say negative n. Right? So I'm going to write negative 60. All that gets put over the interest rate again, 0.00625. And I'm going to close off my parentheses. So to evaluate this, what I would really recommend you do is you take it in parts. So let's first just simplify this 1 plus 0.00625 raised to the negative 60th power. So let's go to Desmos. So again, that's 1 plus 0.00625 raised to the power of negative 60. And that gives me 0.6880918. So I'm going to write all the way up to the 8. All right, so let's rewrite our equation. Oh, get rid of that extra highlight. So 20,000 equals x times 1 minus 0.688 0918 divided by 0.00625. Okay, so at this point, I think what I would do, so we're not going back and forth from the calculator too much, is I would calculate everything here. All right, so let's go to our calculator then. So I'm going to put what was on the top of that fraction in parentheses, 1 minus 0.688 0918, and I'm going to divide that by 0.00625, and I'll get 49.90553. Let's just write up to the 3. Multiplied by x equals 20,000. And now to solve for x here, we would just really divide both sides by that 49.9053. Cancels here. And I get x equals again, we need to go to Desmos to do this. And I get 400.759. This is our monthly payment, so let's round that to the nearest cent. So that would be $400.76. That's going to be my monthly payment. Let me erase part of that. All right, so that's my monthly payment, $400.76. All right, part B. You can pause and write that down if you need to. Okay, so part B. The affordable monthly payment is $300 for the same time period. Determine an appropriate down payment to the nearest dollar. Well, here we're going to have to work a little bit backwards. So we need to first figure out, what did we borrow, right? So in this case, P of N is what we don't know. We don't know what we borrowed. We know our PMT, which is the monthly payment, is $300. We know that our interest rate is the same. So our rate is still 0.00625. And we know our time period here is 60. Okay, so let's figure out, what did we borrow here? That's what we're looking for. P of N equals 300 times. Now, we're kind of lucky here because we already did the calculation that happened in this part of the equation. Let's see if I can circle it for you. Because that's going to be the same. That's all based on the rate and the time period. So I know when I calculate all of that, I could do it a second time if I wanted to, but I don't have to. I'm going to end up with 49.9053. So I'm going to multiply that by 300. Okay, so let's go ahead and do that. Oh, let me erase that. Okay, and so I get 14,971. We could round that to 14,972. Right? So that's the amount we borrowed. We need to know what our down payment is. So our down payment is going to be whatever the cost of the car was. The cost of the car was $21,000 minus the cost of the loan, the amount we borrowed, so that's 14,972. So let's just subtract that. Okay, and we get $6,028. So that's the amount of the down payment if we want that affordable monthly payment. Okay, so that will be the end of this video. We'll do examples 2 and 3 in the next video.